Okay, guys, so if you've never had a good handle on a composition of functions or never even seen it before, it can be definitely overwhelming to try to read and understand via text. And it can be pretty overwhelming to understand in a classroom. So, what I'm going to do is I'm going to present this idea in two parts. So the first part, this video, I'm going to walk us through the concept of what a composition of functions is and introduce the notation. And then, I'm going to have a follow-up example where, a follow-up video where we're going to have some practice examples, okay? So, for starters, let's come up with a pair of functions, f and g, and I'm going to keep them really basic because I want us to focus on the concept and the map and what's happening, and I don't want us to get bogged down in the arithmetic, okay? So the simple functions for this video is we're going to let f of x equal something nice like 2x minus 5, and we're going to let g of x equal something like x squared plus 4. Okay? So we are used to evaluating functions. So the concept that I want us to focus on is let's think of our functions as sort of like input-output machines. All right? So a function is going to receive some sort of input. That's usually the value that we plug in for x. We're going to plug it into some function, and then that function is going to output something else, okay? Typically what the y value is. So for this, to sort of demonstrate what I mean is let's use g. And let's pick a nice, easy value to work with. And let's let x equal 3. So if I let x equal 3, and I plug it into the function called g, g is going to do its magic, like we're used to. And we know what we're going to do is we're going to take this 3 and we're going to plug it in everywhere there's an x, and then we're going to simplify with our arithmetic. So what happens is I'm going to take that 3 and I'm going to plug it into g. So what does g do? It takes the input, it squares it, and then it adds 4. So what's my input this time? My input is 3. So then I simplify that. G spits out 3 squared is 9. 9 plus 4 is 13. Okay? So another way that we've said this in the past is g of 3 therefore equals 13. So now, if I want to do a composition of functions, these are functions acting in a sequence. So if I want to compose the function f with the function g, then what happens is I'm going to take a number like 3, I'm going to plug it into one function first. That function is going to output something like 13, but then because we're going in sequence, I'm going to take that 13 and I'm then going to plug that into the other function f, and we're going to see what f spits out. So what does f do? F takes the input and multiplies it by 2, and then it subtracts 5. Well, what number is being input into f? 13. So then I simplify. 2 times 13 is 26. 26 minus 5 is 21. Okay, so conceptually, what happened is when I took the x value 3, I plugged it into g first. G then spits out a 13. Take that 13, plug it into the other function f next. And so then f spits out final 21. All right? That's all that's happening. We'll get to the notation in a minute. But one of the things that I want to point out is what if I took the same number 3 and plugged it into the C, oh, no, that's the wrong color. and plugged it in to the sequence of these two functions again, but this time I switched the order. So I'm going to take x equals 3, but I'm going to plug it into f first. See what happens, and then I'm going to take whatever that spits out and I'm going to plug it into g. So if I start out with x equals 3, I plug it into f. F receives the input and then does some mathemagic with it. What does f do with its input? It multiplies it by 2, and then it subtracts 5. So f receives the input of 3. So according to math, 2 times 3 is 6. 6 minus 5 is 1. So f is going to spit out a 1 when it gets an input of 3. So that output of 1 becomes the input of g. So what does g do with its input? It squares it, and then it adds 4. So what are we going to plug in? We're going to plug in that 1. 1 squared is 1. 1 plus 4 is 5. And what's worth pointing out at the beginning right here is notice when I took x equals 3, let me point up here, plugged it into f and then g, I got a different value, 5, than when I took 3, plugged it into g first and then f, 21. Okay? So when we write a composition of functions, the order in which things get applied matters greatly. Okay? So let me see if I can figure out how to make this. I want to jump to the notation. I know what I'm going to do. Okay. Hold on to your seats. So now let's mathematically talk about the notation that we use to describe this process. Okay? When we write a composition of functions, we can write this one of two ways. So the first way is sort of a traditional way that we write it is, and I apologize if I sound like I'm repeating myself a lot. I know I am. Sorry if it's annoying, but I just want to be able to make sure we don't miss any dots when we try to connect everything together, okay? So if we followed the mat, we took x equals 3, and we plugged it into g first. Agreed? So when we, so another way to say that, oh, I'm so sorry. I even had this rehearsed before I hit record. Whatever. So let me rewind. I took 3, I plugged it into g first. So that means when I got around to plugging it into f, f came after g. F followed g. G first, then f. Agreed? So the way we write this, the notation that we use, is I open up a set of parentheses, and if f followed g, then I write f, and then a small open circle that's not an O, it's not a dot, and it's not multiplication. It's just a small open circle that's sort of in the midline of the letter. And then the function that f followed was g. I'm going to close those parentheses, open up a new parenthesis, and my input initially was 3. So close a set of parentheses. So right now, I'm going to write this down in words, but I'm going to say it first. What I'm looking at is f following g of 3 equals my output 21. Okay? So I'm going to read this as f following. That's the magic word. If I train my eyes to read that as following g of 3 is 21, then that's going to help me get my order straight. Remember from our previous example, or from our previous slide, that order really matters. And if I get this out of order, I'm going to get a wrong answer. Okay? So f following g of 3 is 21. Okay? So another way that we can think about this is, did I plug 3 into both functions? No. Right here, I took 3, and I only plugged 3 into g. What number did I plug into f? It wasn't 3, it was 13. Where did this 13 come from? Do you guys agree that that 13 is equal to g of 3? I got the 13 by plugging 3 into g. So if that's true, this 13 that I plugged into f came from g of 3. So notation-wise, another way that I could write this is, I evaluated the function f for what? I evaluated it for g of 3. And what did that end up equaling? It ended up equaling 21. So if I were to read this out loud, this would be read as f of g of 3 is or equals 21. Okay? So what I want to point out here is this is one way that I can write this composition down. F following g of 3 is 21, or I can write it like this. F of g of 3 is 21. Now, what I also want to point out about these two very similar but different enough notations is look at the important characters. F, G, 3, 21. What order do those characters appear down here? F, G, 3, 21. Notice they follow in the same order. It just looks like we shuffled some parentheses around and stuff, okay? Most of the time, when you guys encounter a composition of functions in this course, it's going to look like this, okay? By the time the handful of y'all get to calculus, we're going to be using this notation more as a default, okay? And I know many of you are not going on to Cal 1, and that's okay, but I do have to prepare those guys that are going on to Cal 1. And these are two equally good ways of writing this composition, okay? So this was the first example that we did. We plugged 3 into G first, and then we took the 13 and plugged that into F. How would I write it the other way around? So we can more quickly go through this. When I took 3 and plugged it into F first, and then took that output and plugged that into G, and then that was, if it was F first and then G came after F. G was following F. So if I want to write it using my sort of following notation, then I have parentheses, G, open circle for following, F, close parentheses, open new parentheses of 3, that was my input, and then my ultimate output was 5 this time. Okay, so that was G of F of 3, or alternatively, since this 1 that we plugged into G was really F of 3, and that's what we plugged into G, we could write this as G of what? What did we plug in? We plugged in F of 3 equals 5. Okay? One more thing that I want to say about this notation is here I think it's clear that we plug 3 into F. Just because I actually wrote some exaggerated parentheses here, and I changed colors, and it makes things a little more obvious that we evaluated f of 3, and whenever we got f of 3 equals 1, we took that and plugged that into G. Okay? Here, it's a little less obvious what we're supposed to do, other than I'm going to take G following f of 3, but another way that we can think about this is I'm going to take this 3 and I'm going to plug it into the function closest to that 3 first. So I plug 3 into f, and then whatever f of 3 is, that's what gets plugged into G, and that's how I end up with 5. Okay? So I'm going to end this video here, and we'll pick up with just some examples to practice this idea with and get used to the notation. All right.